Okay, welcome to the class. Today we will continue with the same problem, which is on principles of inclusion and exclusion. And this question has appeared in the year 2018 and 20 for 5 marks and 7 marks. So I'll start explaining this. Similar kind of problems, many are there in the textbook. I want you to work out yourself similar kind of problems. For that, you have to listen to this class very carefully and understand. If any doubts are there, let us know. So in how many ways can the 26 letters of English alphabets is permuted so that one of the patterns, say car, that is one pattern, dog another pattern, fun or bite occurs. So these alphabets together occurs in that. So what kind of permutations that you can perform for total of 26 letters. So we'll start with the explanation. Here you have to extract as usual the information required for principle of inclusion and exclusion formula from the given data. So mod S here is 26 letters. So we'll understand what is A1, A2, A3. So here the word A1 is, you can consider that as a set of all permutations in which CAR first pattern appears. Car appears, okay. So that means totally there are 26 characters. Out of this pattern to be occurred means all these 3 characters to be removed first. Okay, so 26 minus 3. So totally how many are there now? 23. 23 plus this pattern, CAR pattern. This is treated as 1. This pattern to be included here. So that becomes A1 set here. Okay, so 24. That is mod of A1. Similarly, mod of A2 is, there are totally 26 characters. In that, I should remove the characters of the second pattern first. There are 3 characters, remove it. It becomes 23 plus include that pattern together because they have told that pattern to be there. Okay, so as a single component. So this becomes now single component 1. So totally 24. Similarly, you can also do for A3. A3 also same thing 24 because the size of this is again 3 characters. Remove that and add 1 fun as a single component and it becomes 24. And the last one is byte. So A4 is, now it becomes 26 minus how many characters? 4 characters. Remove that 4 characters. It becomes 22 plus include byte itself as a 1 component. So it becomes 23. So these are the 4 sets which we can extract from the given data. Actually, when we say that we need to do permutations on 26 characters, so permutations of yes becomes 26 factorial. So that I have missed here. Include that 26 factorial actually it is. Now this also becomes permutation, then it is 24 factorial, 24 factorial, and this also 24 factorial, 24 factorial. So those are all our data now. A1 is 24 factorial, A2 is 24 factorial, A3 is also 24 factorial, A4 is 23 factorial. So all individual sets are computed. Likewise, you have to also find out two sets together. So intersection of two sets. So we'll start that here. For a particular problem, intersection of two sets. Let me take A1 and A2. Similarly, you can also do for A2, A1 intersection A3, and it is also same as A2 intersection A3. Why? Because all are having same size. So it doesn't matter with respect to final value. So we take for all these same thing. Totally there are 26 characters. In that I should remove how many, because I am including two sets here. If I include these two, it becomes totally 6 characters. So remove that character, 6 character. Then since I have to include both as single patterns, car and dog. So this is one pattern, this is another pattern. It becomes plus 2. You are removing and adding. Principle of inclusion and exclusion. So it becomes 22. And that factorial you should consider, because it's a permutations of this count. Similarly, we do for other combinations. A1 intersection A4, because the size of A1 is 3 and size of A4 is 4, 3 and 4 combinations. So similarly, A2 with A4 is also same value, and A3 with A4 will also give you same value. It becomes totally 26 minus, remove the count. What is that count? This is 3 from one character, one word, and 4 from byte. From byte, 4 characters, and 3 from other 3 categories. That is, it could be car or dog or pun. From all this, you will get 3 characters, any one of this. So that becomes 7 here. That plus 2. So you are removing that individual characters, then including each one as a separate object or separate pattern. So you are including 2, it becomes 2. So totally 21 factorial. In the similar way, you should also do intersection of all 3 sets. That is A1 intersection A2 intersection A3. So what happens here? 26 totally minus, you have to remove all these characters. So there are 3, right? Not 4. So 3. I should take first 3. It becomes 9 characters to be removed, plus include all individual words as it is, as a one pattern. So it becomes plus 3. So totally 20 factorial it is. Intersection of 3 sets, this one. Then intersection of A1, A2 and A4 and other combinations. If you take any 2 from this and 1 this, will become intersection of 3 sets. So that combinations will result 26 totally minus 10 characters, because from these two, 4, there are 3, no? So 4 plus 6 becomes 10. Plus include 3 words as a separate pattern. It becomes 19 factorial. That is with respect to 3 sets which has a different size. After doing all these combinations, the last one is intersection of all 3. So when you do intersection of all 3, A2, A3, A4, it becomes 26 minus, remove all these characters. Totally there are 13 characters. Remove that, plus include each one as individual patterns. So add 4 to that, and that factorial. It becomes 17 factorial. So after computation of all this, you need to find out the permutations for A1 bar, because the question is none of the pattern is been asked. So A1 bar intersection A2 bar intersection A3 bar intersection A4 bar. It becomes 26 minus 13 plus 4 factorial. Totally 26 are there, minus 13, then 4. So it's okay. So that is all about this result. You need to compute this value, no? So for that, as per the formula, mod S you should take. Mod S minus union of all these sets. Union of A2, union of A4. And this computation is already done. Individual computations are done. You have to substitute that here. Mod S minus summation of all singleton sets plus summation of all I intersection Aj, two sets, minus summation of intersection of three sets, Ai, Aj, intersection of Ak, and all four. So since only four terms are there, the last term would be of this kind: A1 intersection, A2 intersection, A3 intersection, A4. So substitute all these values. Totally there are 26 factorial. That is the value of this term, 26, minus whatever value that we had computed for this. Include that. Similarly, include these two sets value. Include this minus 3 set value. Finally, the last value which is computed here, that is minus plus 17 factorial. So after substituting all this, simplify that. That would be your final answer. So that is the answer for this kind of questions. So what you have to do? You have to first remove the characters, individual characters from the total number of letters. Individual letters has to be removed. Then you have to include this as a single pattern in that. So that is the overall step.